Assalamu alaikum everyone. My name is Muhammad Uzair Akbar 20TE16. Today we are going to perform our last lab for DSP assigned by Sir Dr. Muhammad Jameel. So here we go. We start with the first task of this lab. First of all, we will perform lab 9 and then lab 10. So moving on toward this lab, we start lab 10 of lab 9 of this lab, where we have given numerator and denominator values, and we need to run this for pole and zeros. So similarly, numerator shows zeros, and while denominator shows poles. X is showing that it has one pole, and 0 is the word 0 on the graph shows that it has 0 at 0, while pole at 0.5. Similarly, moving on toward the next task of this lab, we have values for numerator and denominator. We simply put them on MATLAB and we run them. Similarly, when we run, we get a figure like this. We can see that one of the pole is out of the circle, so this is an unstable system, because three zeros are inside the circle, but we need to see the poles only which are outside the circle. One of them is outside the circle, therefore this is unstable system. So we perform so. And now moving on toward the lab task 3, and similarly we have same values, but I mean to say same numerator and denominator values, but different number values. So we copy them. These tasks were given by the teacher to us, and we are performing them. So as we run it, we have an error, but we change b roots. We need to clear it and do it to be denominator. B is equal to denominator. When we did it, so now we will run it, and this is our result for. And we can see that the poles are, one of the pole is at the line of the circle, so this is showing the marginally stable system, because poles inside the circle shows the stability of the system, outside shows stability, and on the line shows marginally stability. So similarly, moving on, we have numerator 1 and denominator 1 by 2 0.5 means we run it, and we can get 0 on at 0 and pole at minus 0.5. Similarly, moving on toward the next task, we have values for numerator and denominator. We need to change it b value for as to be denominator, and now we have a lot of zeros and poles, and one of the zero is out of the circle, but this system is stable because we need poles to be inside the circle at any cost for the system to be stable. So this system is also stable as all the poles lie inside the circle except that 0. Now moving on, we have another task, which is now we see that again that task 3, we need to perform again denominator, and we put this value for z as well, z plane as well, for z plane, and we see this marginal stability of the system as one of the pole is at the line of the circle, unit circle, so this is marginally stable system. Moving on to the task 5 of this lab, we have numerator denominator values, and we need to perform them, and this is all to go through, and it is same. Now we perform lab 7 or lab task 7. So Now this is also a stable system, since only zeros are outside the circle and poles are at the circle, marginal stability is shown. So now moving on, we have all the tasks same as performed before. We can see that these are all showing stability of the system. We need to run as before, and just a change in the values, but we have seen. And now this value is showing that the poles and zeros are at over one another. So this is also, and similarly they are at the unit circle, line of the unit circle. Now moving on, you can see that we have the next lab, which is lab 10. We need to perform DSP system. We have been assigned some of the tasks are given. We need to just write and run them, but some codes we need to generate impulse. In this task 2, we need to generate an impulse response of the system and step response from numerator and denominator values given to us. So we have impulse response value need to find, and value of n is also given. So first we find impulse response, then later on we will find step response of the system, and system response we will check system response as well later on. So first impulse response. So this is the impulse response of the system. Now we will remove impulse response and we will take step response values. So this is inverse of that a little bit and more values. Now the final system response we get, and this graph is showing system response. Similarly, we move on. Lab task 3 is same as discussed before, and we have now two different values for that. And similarly, now we will perform lab task 5, which have a sampling rate of 8000 hertz as well. We need to determine the frequency response. So we write a code of this length 19. So we have assigned values with the value of sampling frequency A, B, and value of number of samples is also given. So we draw that frequency. For the frequency we will get a phase response and the frequency response as shown. So now moving on with this task, for that task we have given the code, but we will simply put that and we will get result. Now performing the lab task 7, we will perform this task by putting our values for the zeros and poles of the system, and therefore we have a filter 1. As we have been given two filters, so we will perform for the function for the first filter first, and then for the second system. So therefore for the second filters, therefore we have been assigned these values and we have write the code, and this is the result of our this code. As we can see that the poles of this system are outside, so the system is said to be unstable. Similarly, these two graphs are showing instability, and just a little change in the length of the poles may have distance from the x-axis and y-axis, due to which is the difference due to the value of changing